Okay, so yesterday we talked about converting our decimals into fractions by using their place values. Today we're going to go ahead and start working with it. Just like with whole numbers, you remember when we did whole numbers, if we had something like 328 plus 531, we had to line up the columns because when we add or subtract, we can only combine things with the same name. And that goes right down to the individual digits and place values. We can only combine ones with ones, tens with tens, hundreds with hundreds. The same goes for our decimals. We mentioned this before, that when we work with decimals, when we add or subtract decimals, we have to do what with the decimal points? Line them up. And the reason for that, let's say I have 3.27 plus 17.9. The reason we have to line up those decimal points is the exact same thing we're doing over here, is we can only combine digits that have the same place value. So lining up that decimal point, make sure that the ones are with the ones, the tenths with the tenths, hundredths with the hundredths, and so on. So we line up that decimal point. We really should fill in missing place values, like that one there, after the decimal point, so that things line up. When we add, it's not quite so serious. When we subtract, it becomes vital to fill in those missing decimal places. So 7 plus 0 is 0, or 7, sorry. 2 plus 1, or 2 plus 9, 11, so 1, carry the 1. Now before we do the next column, what should we do?
Drop the decimal.
Drop the decimal point. Then we have 1 and 3 is 4 plus 7, 11, so 1, carry the 1, and 2, so 21.17. It gets a little tedious lining up the decimal point sometimes when we have something like this. But we still have to do it. I always just put the decimal point in first and then fill in the digits around it. And of course, we still have to put in those missing decimal place values. This one's going to be really easy to add because there's nothing to combine. It's all zeros, right? So 9803.25. When we get into measurements, we will briefly discuss something called significant digits. I'm not going to hold you to your calculations and stuff with significant digits, but the only reason I'm mentioning it here is when we add stuff, for your purposes, mostly what you're going to be adding is measurements. We're trying to add something like 52.3, 52 and 3/10 to 89 10,000ths. Chances are one of two things is happening. Either, if this really is just measured to the 10th, the error in that measurement is bigger than 89,000, so it wouldn't make sense to add these numbers anyway. Or this was really measured to the nearest thousandth or 10,000. It just happened to come out at the 300 thousandths or whatever. And we'll talk about that more when we talk about measurement. But just wanted to mention that numbers that are this far off in their order of magnitude, the value of their largest digit, it's often awkward to combine them, and there's good reason for that. Subtraction with decimals works the same way. We'll go 13.27 minus 5.684. We still have to line up our decimal points. And when we subtract, it's a little bit more important that we fill in those missing decimal places. Here we got to put in the 0 so that we can line everything up. 0 minus 4, of course, can't be done. So just like whole numbers, we borrow. Borrow from the 7, that's a 6. This is a 10. 10 minus 4, 6. 6 minus 8, got to borrow. That's a 1. This is a 16. 16 minus 8, 8. 1 minus 6. Does it matter the decimal points there? No. Borrow, that's a 2. This is 11. 11 minus 6? It's 5. Remembering now to bring down the decimal point. We can't pass the decimal point without doing something with it. 2 minus 5 can't be done, so we borrow. This is now 12 minus 5 is 7. Again, I'm not going to waste your time with a lot of examples of subtraction, but I do want to show you this one. To do that subtraction, I still have to line up the decimal point. But where is the decimal point in 8? At the end. If there isn't a decimal point written, it's at the end of the number. So then 2.4375. I have to fill in those missing decimals with zeros. Now when I go to subtract, 0 minus 5, of course, can't be done, so I need to borrow. There's nothing here to borrow from, so I have to go all the way to the 8. Borrow from the 8, that's a 7, and that would make this a 10. I didn't need it here, though I need it way down here. So I have to keep borrowing. I'll borrow from the 10 again, that's a 9, that's a 10. Borrow again, 9 and 10, and I borrow one more time. Now I have it down here where I need it. 10 minus 5 is 5. 9 minus 7, 2. 9 minus 3, 6. 9 minus 4, 5. Bring down the decimal point, and 7 minus 2 is 5. Now I realize that decimals work really easy in the calculator, so I understand that you're most likely going to use the calculator for them. But again, keep in mind, okay, this is 8. This is between 2 and 3. So 8 minus 2 is 6. 8 minus 3 is 5. I'm expecting something between 5 and 6 for my answer. So keep those estimates in mind. When we multiply with decimals, like 0.23 times 4.6. It works just like with whole numbers. We don't have to worry about lining up decimal points or anything because we don't need the same name to multiply. We're going to go ahead and we'll start with this last digit of the bottom number, just like we do with whole numbers. 6 times 3 is 18, so 8, carry the 1. 6 times 2, 12, plus 1 is 13, so 3, then carry the 1, but it's a 0, so we just move the 1 over. Just like whole numbers, before we move over to the next digit, we put a 0 here. I also do this. I'll put a line up here above my carries. That way I know that if it's not above the line, it's not a new carry. I see a lot of people make mistakes of, oh, there's a 1 there. Did I just carry that, or is that an old one? Well, now I know it's old because it's below the line. So then I come back here. 4 times 3 is 12. So it's 2, carry the 1, put it above the line. 4 times 2, 8, plus 1 is 9. And then I can add my columns. 8, 5, and 10, so 0, carry the 1. Where's my decimal point go? Well, I have 1, 2, 3 decimal places in the problem. 1, 2, 3 decimal places in my answer. Count from the back of my answer. Now again, does that make sense? Well, 0.23, that's really close to 0.25 or 1/4, right? 1/4 of 4 would be about 1. So yes, just bigger than 1 makes sense. 10 would not make sense there because you can't multiply 4 by something. If you multiply by 1, it would stay the same size. If you multiply by something smaller than 1, it's got to get smaller, right? So multiplying 4 times something smaller than 1, it would have to get smaller. So 10 wouldn't make any sense. 0.1, well, not terribly far-fetched, but again, it's going to get smaller. But if you think of 0.23, or it's about 1/4 times 4, that should be about 1. So 0.1 would be too small. So you have to use those estimates. When we're multiplying, if we multiply by 1, as I said, it stays the same, right? If I multiply by something larger than 1, what happens to the number? It gets bigger, right? If I multiply by something smaller than 1, the number gets smaller. So as we're doing these estimates, this one here I can estimate both directions. I can think of it as being 4.6 times the 0.23. Well, the 0.23 is smaller than 1. I'm expecting something smaller than 4.6. Okay, 1.058 is smaller than 4.6. Think of it the other way around. 0.23 is being multiplied by 4.6, which is bigger than 1. So I'm expecting my answer to be larger than 0.23. So right there I have an estimate. My answer's got to be between 0.23 and 4.6. If nothing else, that helps me place my decimal. The reason I bring that up is the decimal point seems to be one of the buttons that seems to malfunction first on most calculators. And on a lot of calculators, the newer ones are better, but on a lot of the older calculators, and especially your cell phone calculators, the decimal point doesn't show up on the screen until you hit the next button. So you don't know if it registered until you hit the next button, and by then you a lot of times forget to check. So the biggest mistake when doing decimals on a calculator is the decimal point ends up in the wrong place because one of them didn't register. If your calculator gives you 105.8 here, can you tell me which decimal point most likely didn't register? The top one or the bottom one? That'd be the top one, right? Because there's 2 decimal places there and we're off by 2 decimal places. If I ended up with 10.58, then most likely it was the bottom one that didn't register. Your newer calculators now have a 2-line display on them, which is good, so you can at least see the last line that was entered. So when you get an answer, you can always go back up and look and see that those decimal places or decimal points did get in there. Okay, well, dividing by decimals, a little bit tougher. Say 23.86 divided by 3.2. We're going to set that up, of course. 23.86 goes in the inside here because that's what we're dividing. And we're dividing by the 3.2, so that goes outside. It is very, very possible to divide by a decimal. If we use that method that I showed you guys way back in the first week, it's just the exact same method. We go by place values and stuff. Most of us don't do it that way, though. How are we taught to divide by a decimal? Anybody remember? We were taught not to divide by a decimal.
Yeah, you're supposed to move the decimal.
There it is.
2 and then move it to the 8.
Okay. We get rid of the decimal in the number we're dividing by. To get rid of it here, we have to move it over 1 spot. So what do we have to do here? Move it over the same distance, 1 spot. So this becomes 238.6 divided by 32. So we're not dividing by a decimal anymore. Why is that allowed? Why is that possible? Well, remember, we've mentioned that if fraction and a division problem are equivalent, you can slip back and forth between them. So if I express this division in a form of a fraction, one of the things I can do with a fraction is multiply the top and bottom by the same thing. Multiply the bottom by 10, that makes it 32. Gets rid of that decimal. I'd have to multiply the top by 10 as well, which in effect moves the decimal point over a spot there. So I'm really not just moving the decimal points over. What I'm really doing is multiplying both numbers by 10 to keep it equivalent. So anyway, down here I go to divide. Does 32 go into 2? No, so I leave it blank above the 2. Does it go into 23? Nope. I leave it blank above the 3. Does 32 go into 238? Yeah, let's try 7 times. 7 times 2 is 14. 7 times 3 is 21. Plus 1 is 22. So I'm going to subtract there. 8 minus 4 is 8. 3 minus 2 is 1. So I get 18. What must I do before I can bring down that 6? I cannot cross the decimal without doing something about it.
You got 14.
What's that?
14.
14, you're right. Thank you. I don't know how I did 8 minus 4 and got 8.
That's the one of the days, man.
Yeah, it's going to be, I'm afraid. So, we bring down the 6 now that we brought up our decimal point. 32 into 146. Let's try 4, right? 4 times 2 is 8. 4 times 3 is 12. So I'm going to borrow, that's 3 and 16. So this is 8 and 1. So now it is 18. Am I done? If I don't want to be done, what can I do? Add a 0 and bring it down. Let's say I want this to the nearest 1,000. In machining, a lot of times we're going to the nearest 1,000th or the 10,000. So I bring down, add a 0 and I bring it down. 32 into 180. 5 times. 5 times 32 is 160. So that's 20 left over. Another 0? Sure. 32 into 200? Say 6. That's 12, 18, 19. Leaves me with 8. Now I'm at the thousandths place. Am I done? Have to add another 0. Bring it down. Why do I have to go one more place? Well, because right now this is 7.456, 7 and 456 thousandths. I need to know whether I'm going to stay at 456 thousandths or if I have to round that 6 up to a 7. So I bring down that extra 0. 32 goes into 60 or to 80 only twice. That'd be 64 or 16 left over. I needed to have this 2 here to tell me that when I round to the nearest thousandth, that does stay 7.456. It does not round up to 7.457. Make sense? Now that we know this process, we can convert our fractions back into decimals. If I have something like 3/8 and I want to convert that into a decimal, it is the numerator of 3 divided by the denominator of 8. Now, of course, if this is a proper fraction, 8's not going to go into 3, is it? It's 0. Now, before we can add zeros onto the end of our 3, what do we have to do? Put in our decimal point, bring up our decimal point. Now we can add a 0. Does 8 go into 30? Say yes. Yeah, how many times? 3. 3 times 8 is 24. We're left with 6. And I'm going to keep adding zeros until this thing either comes to a nice neat end or we get to a point where we want to round it off. So add a 0 and bring it down. 8 into 60. That's 7. 7 times 8 is 56. Subtract to get 4. Add another 0. 8 into 40 is 5. 5 times 8 is 40. We're done. We have nothing left over. So it comes to a nice neat end. 3/8 is 0.375. Now at this point, some of you may not know that. Some of you may have that memorized. By the end of this year, I would hope that you have the eighths at least memorized, 1/8 of 0.125 and stuff like that. It's going to come up enough in machining that you're going to be able to need to make those conversions back and forth pretty quickly in your head. I know a lot of old school machinists that have been in the business for 15 or 20 years that can actually do the conversions down to like 30 seconds in their head. Okay, some notes on estimating. A little bit of review. If I have 200 or 2,000 times 40 for an estimate, I just do 2 times 4 is 8, and how many zeros do I put in there? 4. I combine the number of zeros, right? If I have 2 thousandths times 4 hundredths, 4 times 2 is 8. How many decimal places do I need? 5 decimal places, right? it's not totally equivalent here, but there is a big similarity here. When we are estimating with multiplying with zeros, we combine the number of zeros. We had 4 zeros there, so we had 4 zeros in our answer. When we are multiplying or estimating with decimal places, we combine the number of decimal places instead of the number of zeros. So we had 5 decimal places in the problem, we have 5 decimal places in the answer. So it's not equivalent, but there's a relationship there. There's a pattern that develops there. It's similar.
So why did you only put 4?
Well, over here there are only 4 zeros.
No, I mean, yeah.
That's 5. It's not the zeros, it's the decimal places. So the 8
Right.
counts and not just the zeros.
Okay.
That is a very good question, though. Yes, the decimal places that count when you're doing decimals, not just the zeros. When we were dividing and estimating, let's say I have 80,000 divided by 400. I would divide. 8 divided by 4 is 2. What do I do with the zeros? I cancel out 1 and 2, and I'm left with 2 zeros. So when I divide the numbers, then I cancel the zeros. Well, it's similar with our decimals. Eight divided by 4 is 2. Here I have 4 decimal places. Here I have 2 decimal places. I cancel out. What's 4 minus 2? 2. My answer is only going to have 2 decimal places. If we wanted to use what we were doing up in our longer division process, we'd move that over 2 spots, and move that over 2 spots, and we're left with only 2 decimal places there. So it's, again, it's not equivalent, but it's a similar pattern. We cancel out zeros, cancel out decimal places when we divide. Okay, with that, I'm going to let you guys practice. In your little books, it is units 11, 12, 13, and 14. Again, do the odds. Give you some word problems to work on.